Today we're going to be working with exponents, and there are 5 exponent rules that you need to know, and most of them you should have seen before. We'll do a practice problem, and then we'll illustrate the law also. So x to the 6th times x to the 3rd. If they have the same base, then if you recall, you can multiply them together by adding the exponents. So that will make an x to the 9th. And to illustrate, an x to the 6th times an x to the 3rd. If you ever forget the rules, you can always figure out what the rule is by just simply expanding it. An x to the 6th means that there are 6 x's being multiplied together. And x to the 3rd means that there's an additional 3 x's being multiplied together. So all in all, you can see that we have a total of 9 x's. All right, so when multiplying, add exponents. Okay, the next problem. Same powers, but now we're using division. An x to the 6th divided by an x to the 3rd. If you remember that, that means that you're going to subtract the powers if they have the same base, which they do, and x to the 6 minus 3 is x to the 3rd. And again, I'll illustrate. And x to the 6th divided by x to the 3rd. And x to the 6th, again, means that there are 6 x's. So it'll look like that. Divided by an x to the 3rd means that there are 3 x's being multiplied. And then what happens here is that this x and that x cancel, these 2 x's cancel, and these 2 x's cancel. And then you're just left with them, which is x to the 3rd. So when dividing, subtract exponents. Okay, so we have 3 more rules. The next rule, an x to the 6th raised to the 3rd power. Again, if you recall the rule, when you raise a power to an additional power, you multiply the power to the power with the power, and you're going to get x to the 18th. All right, and then again, I'll illustrate the rule in case you ever need to figure out the rule on your own. Okay, an x to the 6th raised to the 3rd power. The 3rd power on the outside means that there are 3 of the guys on the inside being multiplied. So if I write that out, actually I'll write down blue. Okay, so that's what the blue means, that there are 3 of the guys on the inside. And then the x to the 6th means that there are 6 of each of those. So 6 in that group. Another 6 in the second group. And another 6 in the third group. So altogether, you have 18 x's being multiplied together, which is x to the 18th. So when you raise a power to a power, you multiply exponents. Okay, the next rule, an x to a 0 power. A 0 power means that you don't have a base, and that means that it's going to reduce down to 1. So anytime you have a 0 power, it's equal to 1. And let me give you an example. So if I had an x to the 5th divided by an x to the 5th, then we already know that when you're dividing, you would subtract powers. And you have it's a 0 power left. Okay, but in addition, when you divide something by itself, we all know that dividing anything by itself gives you a 1. So if we subtract powers and we get a 0, or we divide themselves and they make a 1, since we started with the same two things, these two guys must be equal. So therefore, when you divide and you get a 0 power, it's like dividing by itself, which means it makes a 1. So 0 power equals a 1. And the last one, when you have a negative power, not necessarily the 1 power, but the negative power right here means to reciprocate. And that means to flip. So that would be 1 over x to the 1 power. If it was a negative 2 power, then it would be 1 over x to the 2nd power. Okay, so again, why does this work? If I give you an example, x to the 5th divided by x to the 6th, you're going to get x to the 5 take away 6, which is x to the negative 1. Now, if I do it the expansion way, x to the 5th means that there are 5 of them. X to the 6th means that there are 6 of them. And then if I start canceling 1 for 1, I have a 1 on top over an x on bottom. So since we started off with the same two problems, this and this are the same. Okay, so a negative power reciprocates. All right, so those are the 5 rules. But now we're going to be doing problems in a minute where you have to combine multiple rules in one problem. So order of operations, you'll need to know that. Okay, so an exponent is a power to show how many times the base, and the base could be a number or variable or expression, and then how many times you're going to multiply that base by itself. So a 2 power means to multiply the base by itself twice. A 10 power would mean to multiply the base by itself 10 times, etc. All right, so the first rule, the product rule. Now notice we have letters in there. In math, we use letters to just say this is a general pattern we're going to do. So A and B could represent numbers. So this is just saying that if you have an x to some a power and you multiply it with an x to some b power, that we're going to keep the base, and that's important that you keep the base, and you're going to add the exponents. Okay, so in our first example problem, we have an x to the fifth y squared multiplied with an x to the third times y. So because we're multiplying, everything's being multiplied, I can start pairing up like bases. So an x to the fifth and an x to the third. We would multiply those two and add the powers, and that's x to the eighth. And then our y to the second times y would be like saying y to the 2 plus 1. There's a 1 power when there's no power given. And that will condense to y to the third. Okay, our next problem. When you have an x to an a power divided by an x to a b power, we talked about that you would subtract. And it's not highest power minus lower power. It's the numerator power minus the denominator power. So that's really important. Again, you keep the base, so they must be the same base, and you subtract the exponents. Okay, I think I'd rather highlight than circle. I think it drowns it out. So I'm going to get a highlighter, and you may want to too. So we have an x to the eighth divided by an x. It's going to go together. And then we have a y to the fifth and a y squared. All right, so our x to the eighth divided by an x is really like saying x to the 8 minus 1. So you're going to get x to the 7th. And then the y 5 divided by y squared is really going to be y to the 5 take away 2. And you get x to the 7th, y to the 3rd. Now, you don't have to show the subtraction steps. You'd only have to show this as your answer. But in the beginning, you may want to just make sure that you're understanding what the rules are. So doing it out the long way may help you. All right, the next one, power rule. So if you have a base that has a power and you raise it to an additional power, the rule states that you're going to take the two powers and multiply them. Again, you're going to keep the base. That's why it's important they're the same. And you multiply the exponents. Okay, so on problem A, we have an x to the 4th all being raised to a 3rd power. So you keep the base, you take the 4 power and you multiply the 3 power, and then you're going to get x to the 12th. Okay, part B. This gets a little trickier because now there is a front number 2 involved. Now, I want to stress that these rules only apply to a power. So a common mistake is students want to take a 2 and multiply the 3 with it and say a 6. But basically, the 2 is the base. It's not a variable. So there's really a 1 power there. So if it helps you to put the 1 power there so you actually know that you're going to do 2 to the 1 times 3 power, you're going to do x to the 4th times a 3 power, and you're going to do a y squared times a 3 power. So that 3 power goes to all 3 bases, the 2 base, the x base, and the y base. And then you have a 2 to the 3rd power, which is not 6, it's actually 8. Now you can do that in your calculator if you want. Just be careful that you do a power and not a times. And you'll get your 8. And then you have an x to the 12th and a y to the 6th. So just real caution on that 2. That's just a very typical mistake. You want to make sure that 2 to the 3rd power is a 2 to the 3rd power and not a 2 times 3. That does not follow the multiply rules. That's a 2 base. Okay, and lastly, we have the 0 power rule. All right, and a 0 power rule, as we already said, makes the base equal 1. So anything that has a 0 power attached to it equals 1. So if you look at our problem to the right, we have this whole group being raised to a 0 power. That means every single base is going to change to a 1. So the whole thing is going to end up equaling 1. Okay, and the last one, a negative exponent. Okay, it has nothing to do with the number itself. It has to do with that negative. The negative means to reciprocate. Reciprocates the base. So you're going to have a 1 over x to the positive a power. So all the negative does is take off the negative if you flip it around. The power a itself will stay the same. So if there's a 2 power, originally a negative 2 power, it will go to positive 2 power down below. You also have to be careful about which the power goes to what base. So in problem A, the negative 3 power is not going to both items, all right? The negative 3 power is only going to the x base. So therefore, it's not touching the 2 at all. So the 2 is staying the same. And this guy right here, he's going to flip to the bottom. And you're going to take off the negative because that's what the negative means, to flip it. Now in part B, the negative 3 power is in fact going to the whole thing. So that means that the negative is going to flip. And therefore it takes off the negative. And then the 3 is going to be brought to both items. So in the end, you have an x to the third, and then a 2 to the third again in your calculator is 8, not 6. Okay, so that is doing some more elaborate, and now we're going to put these all together, and these problems are going to be a little bit involved using 1, 2, or even 3 of these rules. So order of operations, you just have to think about what you need to do first. Sometimes you can do anything you want first. Sometimes there's a specific thing you have to do. So problem number 1, we have to simplify 2x to the 4th raised to the 3rd with a times the 3x squared. Well, in order to multiply these two, I can't do that right now because this 3 power is in the way. So definitely without a doubt, if you have a power to a group, you have to do that first. Okay, so if you have a power to a group, there's no question about it. You can't multiply until you get rid of that outside power. So the first thing we're going to do right now is just focus on that guy with the power. So I'll highlight it. So that's our power to power rule. So our power to power says that we're going to distribute the power to each guy inside because it's multiply. So you're going to get a 2 to the 3rd, which is an 8, and then an x to the 12th. So that is the power. And then we still have the 3x squared. And now in order to multiply these, we multiply the 8 and the 3 to get 24. And then an x to the 12th and an x squared. You add when you multiply the powers. So you get 24x to the 14th. Now I went slowly to show every step, so in your notes you know where everything came from. You do not have to be this elaborate. You can like skip and just do where I'm doing the equals. You have to have what I have for the equals. You can skip the other 2 lines if you don't need to have them. Okay, problem number 2. We have a group being multiplied with a group, and there is no outside power to a group. So at this point I can do one of 2 things. I can multiply together the group and make it one group, or I can get rid of the negative power. And the reason why I want to get rid of the negative power is my original directions, which I should have read, said that you only want positive powers. Now, it's up to you. It's your personal preference. If you don't mind working with negative numbers, integers, then you're okay to start the multiplying process. If you're really bugged by that, you can flip the negative 3 power down to the bottom and then work with a positive. So I'm going to stay with not flipping it first. So a straightforward multiply, I'm going to multiply the 3 with the 2 and make a 6. Then the x to the second and the x to the third are like bases, and we're going to add the powers. And then the y, now that has a y to the 1, and that's going to be multiplied with a y to the 5. So you're going to add the powers. All right, so 2 plus negative 3 is negative 1, and then a y to the 6th. So since the directions said only positives, it means that I cannot keep this guy here. So in order to get rid of a negative, that means I need to flip. And I'm only going to flip the x because he's the guy that only has the negative power. So the 6 is going to stay. The x is going to flip to the bottom, and that's an x to the 1 power. And y to the 6 is going to stay because it also was a positive, didn't move. And that would be your answer. Problem 3, we have division going on. So when you're dividing, again, there is no power to a group, so I can go ahead and start dividing. So there was really a 1 there. 1 and 4 is still going to stay 1/4. Okay, an x to the 6th and an x to the 5th, you would subtract. Y to the 3rd and a y really means 3 minus 1. And then a z divided by a z. Now that's going to cancel. If you already know that, fine. Otherwise, you're going to do z to the 1 minus 1, which would be z0. Okay, at this point, we do our subtraction. Now that's an acceptable answer, or you might see it with the 4 on the bottom, and then the x and the y squared in the numerator. So either answer is acceptable. Okay, number 4. So I have two things being divided, but I have a power being raised to one of the groups. So anytime you see that, you have to do that first. Okay, so power to power, I'll just do that here. You're going to have a 3 to the 2nd power, y to the 3rd to a 2nd power means multiply. Y to the 1 to a 2nd power, we multiply. So that's going to make 9, x to the 6th, y to the 2nd. All right, so I'm just going to rewrite that. Okay, so now I'm dividing, and when I divide, I can subtract powers. But again, your original coefficients, 18 and 9, they get divided like normal. So 18 divided by 9 is 2. So then we have an x to the 4 take away 6, and we have a y to the 5 take away 2, which gives you 2, x to the negative 2, y to the 3rd. And then to get rid of that negative 2 on that power x means I have to flip him around because he has the negative power. 2 stays on top. X to the positive 2nd flips to the bottom. Y to the 3rd. Okay. We'll try 4 more problems. Okay, number 5, we have 2 groups being multiplied again. So that was similar to problem 1. The only difference is that we have a negative 2 power. So although there are a couple ways to do it, anytime you have a power on the outside, you have to take care of him first. But in addition, if you have a negative, that means I want to flip the group. Take off that negative on that group. So the 3x to the 4th y group is going to be flipped to the bottom and now have a positive 2 because the flip took off the negative. And then I still have my x to the 6th, y to the 3rd that I didn't change, and it's still up there. So I still have to now get rid of that power 2 on the outside of the group. So I still got to take care of him. So I'm going to keep the x to the 6th, y to the 3rd. And then the bottom group, we're going to have a 3 to the second, x to the fourth times 2 power, y to the 1 times 2 power. And that really is going to make a 9, x to the 8th, y to the second. Okay, and lastly, to divide, I have a 1 divided by 9. Then I have a x to the 6th divided by an x to the 8th. And then I have a y to the 3rd minus a y second. So we're going to have an x to the negative 2 and a y to the 1. Because I have to get rid of the negative exponent, I do have to get rid of this. And again, I apologize that the negative keeps on happening on the x. The negative can happen on both terms or just the first or the second term. But I have a 1 and a 9. The x to the negative 2, the x squared is going to go to the bottom and join the 9. And the y to the 1 stays up here. Okay, the next one. We have division going on. So again, I can do one of two things. There's no outside power to a group, so I can go straight to the division. If you want to flip the negative powers around right now, you can, or you can straight up just right now go into the dividing. So this is what that would look like if you just went strictly to dividing. The x to the negative 5th, take away a negative 8. You're going to have a y to the negative 3rd, take away a 2. Remember, it's always top power minus off bottom power. And then you're going to have a z to the 1 power, take away a negative 1. So just be careful. When you subtract negative 5, take away a negative 8, you're actually going to get positive 3. And you can do that on your calculator. But when you subtract, you're really adding the opposite. There's your positive 3. Negative 3 minus 2 is negative 5. And then z to the 1, take away negative 1, is actually going to add up to be z to the second. Okay, and again, only because my direction said so, I have to get rid of this negative on the 5. So that one's going to flip. X to the 3rd, z squared is going to stay. And then y to the positive 5, the flip takes off the negative. Okay, next one, we have a couple things going on. We have multiplication, and then we have division. It's always best to combine the two on top together to make it one term before we divide. So we're going to go ahead and do that first. And again, there are multiple ways to do these problems. If you do it a different way and it ends up with the same answer, then you're using your rules correctly. It's fine. Multiplying, we get negative 2 times 9, which is negative 18. X to the 4th times an x would be x to the 4th plus 1. Y to the negative 2 times y to the 5th would be negative 2 plus 5. And then we're going to keep the denominator. So I'm going to finish off and simplify the numerator first. So 4 plus 1 is 5, and negative 2 plus 3 plus 5 is 3. Okay, now we're division. We're going to divide the numbers like normal. So negative 18 divided by 6 is negative 3. X divided by x, you subtract the powers. And then y divided by y, you subtract the powers. So just be careful when you're working with the negatives. And there are no negative powers. Please be careful. This negative 3 does not mean a flip. It only means a flip if it's a power in the negative. So negative 3 is okay. So that would be your answer. And lastly, the last problem. So I have a negative, or I have a power on a group. So I definitely have to do that first. And the negative on the group means I need to move that whole group up there. So that's going to look like this. 3x to the negative 8. Y times because that whole group is going to join them. So I apologize. Let me move this over. So that whole group is going to join them, and you're going to have the 2x squared y to a positive 3. So that's the first thing that's going to happen. Then the next thing I have to do is now bring the 3 power in. So that's going to have a 2 to the 3rd power, x squared times 3, y1 times 3. So before I even touch the first group, I have 8 x to the 6th, y to the 3rd. All right, this group I'm going to bring down now. And now I'm going to go ahead. So I moved the group up, I brought in the power, and now I can go ahead and multiply the two groups together. 3 times 8 is 24. Negative 8 plus 6, and then y to the 1 plus 3. So I have 24 x to the negative 2, y to the 4. And then lastly, bringing down the power, the negative power, that's going to flip. And that's your final answer.